Okay, so this should be recording now. This is for the lecture of Tuesday following Labor Day. And for the Monday, Wednesday crowd, this is the one that substitutes for the Labor Day lecture that you would not be getting. Sorry to make you work a little extra for this, but this will be a short lecture. Kind of good news for a lot of you, as we had the meeting on Friday, hour and a half. Turns out my class is ahead of everybody else, so I guess I'm going a little too fast, which means we'll get to slow it down a little bit. I found out that some people weren't even out of chapter 1 yet. So those of you counting on finishing chapter 4 by the midterm, not going to happen. But the plan is to get to chapter 3, and that I'd have to say is not even 100%, but we're going to do the best we can with that. Today I did want to cover 2.6, which looks very brief, and 2.7, which has a few little nuggets there, but looks like 2 sections per day would be plenty, and we do need to get the Jupyter notebooks. I've got the email going out as to how to get that going for you, and we'll look at that. But 2.6 hints at the Jupyter notebooks, but it doesn't actually get them. But anyway, let's go ahead and dive in. Let me maximize the screen for those of you that want to do that. Well, okay, not too much. The structure of data. Data can come to us in many forms, as you see. If you collect data yourself, you may start off with numbers written on scraps of paper, or you can get a computer file full of numbers, or just stuff on a clipboard or whatever it might be. So yeah, you want to. It's necessary to organize and format data, so it's easy to analyze. And if everybody's kind of on the same page with that, it shouldn't be a problem. But if people were doing it differently, you would then have to standardize it one way or another. This idea of tidy data just seems like extremely basic data to me. Each column going down is a variable. We can see this here. There's sex, gender, race, ethnic, family members, year, job, etc. Those are all the variables. And each row is each individual person, each individual observation, 6 of them. Clearly they use the head command for that one. Each type of observation is kept in a different table. So if you're suddenly going to compare apples to oranges, well, they'd do that in a different table. But this is called a data frame in R. It's unique to R. And so we have the idea that we're not supposed to mix observations in a single table. In other words, you wouldn't have rows of college students intermixed with rows of cars or countries or couples. They all start with C. That's not quite exactly what we want to do. You'd have to have a separate table. They'd each go into a different table. And this is just an output of what we looked at before, I guess, with the top 6 of those observations by all the different variables. They have a little question here in the fingers data frame. What do the columns represent? We just talked about that. They're the variables, of course, and then you could list all the variables you see, or a few of them if you wish. And the rows are representing the individual observations, in this case, individual people. Now, back in 2007, a Harvard psychologist recruited 75 female housekeepers working in different hotels. She informed about half, 41, that the work they do satisfies recommendations for an active lifestyle, and gave them examples for why their work is good exercise. So that's actually a very nice thing. And of the 34, a little less than half, weren't told anything. So they're just sort of like the placebo group. And they recorded them before and after, 4 weeks later. Now, the people noticing it's an active lifestyle, maybe they put a little bit more vim and vigor into their work. Maybe they decided to work a little harder and get it done and try to lose some weight or just get in better shape from many different standpoints. They've got the before weight, the after weight, the body mass index. Apparently this is fat of some kind, and I'm not sure what WHR stands for. Anyway, the data is in the Mindset Matters data frame. The first few lines are listed below. And the condition is either 0 or 1, but we're going to get to that in a minute. Here's a different data set called the Happy Planet Index. And these countries, in alphabetical order it seems, are ranking their level of happiness. This is a scale from 1 to 10. So you can see that Argentina has a 7. Australia has a 7.9. But Angola, unfortunately, only has a 4.3. And those are just a few that we can see. And there's a few other variables there. One challenge for students is to keep track of the difference between an observation of housekeepers, countries, a variable, and the values a variable can take. So we have the variable like weight or sex or happiness. Then the columns but then the values are not the same as a variable. Variables should take on various meaningful values, but they look and almost sound the same. They're really not the same thing. So we put it all into what they call a tidy format, just the standard format. And we've already been doing this already. Now this is something that we'll be talking about soon, probably even next time, as soon as I analyze how we do the Jupyter notebooks. I did them in the summer, but I never had to do them. They're already done for me, so that's a different story. I'll have to do it myself. I don't think we're going to be using RStudio, but we will be using the Jupyter notebooks. So because we are a little bit ahead on the sections, I'm going to definitely be spending more time on those coming up. So anyway, Data Camp is just basically the name of the book, I suppose. And here's another way to do it. This is not the way we're going to be doing this. I've not really been a user of Google Sheets, and they have a few other inputs you can try, and then this kind of stuff can be done. But we're going to be using Jupyter Notebooks. So this kind of supersedes most of this section. Luckily, there's only one R window that has anything to do with it, and I couldn't get it to run. So as I say, one out of literally dozens or hundreds isn't going to really affect your grades. So if you happen to play around with this, fine, but this part is not necessary. The Jupyter notebooks are really much more important to us. So this one will basically be ignored, and I'll just remember that the only one. Well, we do have some more participation points here, so a few answers there. So it's, there's like 4 long form answers in one R notebook. That's not going to be enough to really make anybody lose any real points. Do not be concerned about that. So let's go over to, as I shrink the screen down so I can go to the next one, we'll just go to 2.7. There's a few little nuggets in here, and this will be as far as we go today. This could be ready as soon as the Saturday before Labor Day. For the Monday, Wednesday crowd, remember this is the additional lecture that you lose because of the holiday, just to keep you up to speed. Luckily, we've been going a little on the fast side, so that's not a serious major issue. So I shrink the screen down so you can still see it. So once the data are in a tidy format, we can use our commands to manipulate the data. We're going to look at the first 2 or 3 of these here. Identifying missing data is important. Filtering data is important. Creating summary variables, and some of these others will just have to wait till the next lecture, or maybe even beyond that as we go into some of the notebooks. Identifying missing data. Let's start with that one, the first of the little bullet points they have for 2.7, the title of which is Manipulating Data. Sometimes, in fact usually, we end up with some missing data in our data set. R represents missing data with the values NA, just NA, not available, and lets you decide how to handle that. Sometimes people put like big negative numbers. I've never been a fan of that. What if they got averaged? And you should record them as NA when working in R. So that's kind of what I would do, or leave it blank. But NA is what they want to use. And so the last digit of student Social Security numbers ranging from 0 to 9 is called SS last. It's from the fingers data frame. And first arrange the fingers data frame so the rows are in descending order by SS last. Remember to save it. And then print out just the variable SS last. So they're suddenly asking for quite a lot here all of a sudden, but let me see, I did take some notes here. So looks like what we need to do is to put into the fingers data set on this line number 2 in the script window, the left window, the range, because they did say arrange in descending order, so I'm going to use the command arrange, and then parentheses. And then we're going to also have fingers, that's the name of the data set, and it has to have a capital F, or it will not understand it. Then we'll go into comma, and then descending, DESC, and more parentheses, and by SS last, capital SSL last. And then we make sure we have enough parentheses. We had 2 of them, so we better put a second one on the outside, or we'll give us a mistake. And so what we seem to have done here is to arrange on the left the data set name fingers. And now we want to do it in descending order by SS last, and you probably have noticed the mistake I've made. Nope, only 2 S's in Social Security, not 3. So let's go ahead and run it, but we are going to need to make sure it gets printed too. So we'll need to say fingers $, that's according to their format, to put the variable out of the data set fingers so you don't list them all, and then SS last. So let's make sure that's capitalized, and now go ahead and run that. and see what happens. The hint, by the way, if you wanted to use a range with a descending function, so I've done that, arrange descending function, and then the descending order, and print it out by using, and they even told us here, fingers $SS last. So the hint was pretty good this time. Let's go ahead and run it. I'll go to the top of the page, and it does seem to match, as you see the black printing down below, it does seem to match what they got. Here we have four digits, and it's in descending order, so 9,397 is the top number, and it goes down and down and down and down. And then finally, some students actually followed directions and typed in the last digit, 9s, 8s, all the way down to 0. And then, of course, after the 0 comes several people just didn't fill it in at all. So some people filled in 4 or 3 digits, others didn't fill in anything. So this, the vast middle did what they were supposed to do. Okay, now we have a little quiz here. What are the following are true about it? And some people didn't follow the directions. That's pretty easy. And yeah, so you can take a look at that one. In R, blanks are automatically given NA for not available. We just talked about that. And you can remove them from an individual analysis, or you can remove them from the data set entirely. So which of the following comparison statements would be true if the student had entered some number for SS last? So it turns out, as I kind of give you the answer here, which I probably shouldn't do, SS last is what's in common from all four answers. And this, remember, is the not equal sign. The exclamation point equal is really like a slash to the equal. And so if SS last is not equal to NA, that would be a true statement. So that would actually be true because it's really not equal to NA. Okay, this is a situation where it's more useful to think about what SS last does not equal, because there are lots of numbers that students could have entered in. And so that means that that's what it says. So anyway, the statement would be true for anyone who actually entered in some numbers. And it's false for anyone who did not answer this question. Well, anyway, that's just one way of going about things. The second bullet point was filtering data. And let's see, we can filter the data so we can only see the observations that do not include missing data using the function filter. So this kind of just ignores it. And fingers such that SS last is not equal to NA. So when it's not equal to NA, that means there's something in there. Even if there's too many numbers, at least they typed in something. So that's better than nothing, I guess. So filter filters in, not out. So it accepts stuff coming in. It doesn't exclude stuff. So that's an interesting point. So, okay, so let's go ahead and see what we could do with this one. Filter out the students who have missing data from for SS last. So we have fingers.subset will be replaced by filtering. In fact, it's going to be the same as this. So let me just go ahead and copy this command here as I go through this. And on my Mac, I'll hit Command C, go down here and hit Command V. And that should give us to filter the data set fingers such that SS last digit of Social Security, is not equal to NA. In other words, we only want the ones that have numbers in them. But then to print it out, we have to essentially type that in. So I'm going to hit Command V again, or whatever it is to copy and paste. And so that will simply give us the number. But we do not want to filter on this. In fact, it looks like we would have to, actually I'm incorrect. We need to use the $sign on this one, so I jumped the gun on that one. Let me get another line in there. We're going to need to get fingers.subset, so that part was the same. Fingers.subset, so it'll print that. And $sign SS last, SSL, and then AST. So that way it'll print only the variable SS last from this thing called fingers subset. Let's go ahead and run it. You could look at the hint. Make sure we filter in. We want the SS last data that is not NA. So that's what they'd already kind of hinted us for us to do. Let's go ahead and run it. Remember, you will submit it. Probably a good idea to run first and then submit. This one looks just the same as before, except there aren't any NAs. So it stops at, I guess, variable number 100 or observation number 128 is what's happening here. So that looks all right, and that matches what I have, so very good. Now, it didn't line up perfectly the same as before, but that's just because we have different number of columns and the widths of the screens. Remember, however, if you remove cases with missing data, you may be introducing bias into your sample, and so they ask us about it without really explaining much about this. What kind of bias might be introduced if we removed all the students with missing values on the last digit of their social security number. Well, we might be eliminating some of the students that couldn't follow directions, but then we'd still be including the students up here that still didn't follow directions, or 3 or 4 decimals, digits, that is. So, there'd be a slight bias because we don't have the full data set. What if we could have gotten the full data set with all the correct numbers? Because at least from these, we can see that must be a 7, that must be a 4, and we could pretty much surmise that all the last digits of these would fit. But ones that are NA, we have no idea about. So we've lost some information. I don't know if that's going to make it biased one way or the other, because these numbers are randomly splattered from 0 through 9. Mine's a 5, for example. I don't see how you'd expect people who put down not applicable to always have zeros at the end of their social security number, always have 9s. If they did, that would introduce a bias. It would sway it away from the average. But that's not practical, so there wouldn't really be any real bias. It's just we'd have less of a data set to work with, which is never good. We'd always like to have a bigger sample if we can get one. So bias isn't really the correct way of putting it. So creating summary variables, let's take a look at this one. Often we use multiple measures of a single attribute because no single measure would be adequate. So it'd be difficult to measure school achievement with a measure of just one course. So you just took one class, got an A. Oh yes, I have a 4.0, but I only have 4 units or 3 units. If you have multiple measures, you'll probably want to aggregate them into a single variable. So a good summary measure might be the average GPA earned across all the students' courses, and we assume more than one. So quite common to create new variables to summarize values from other variables. And here, what we're going to do is we're going to average the lengths of all the 5 fingers, and we can do that later on as we finish this up in just a few minutes. So here's an interesting topic, I suppose you could say. We want to examine these finger lengths separately. You might want to create a new variable based on these finger lengths. So here we're going to just see whether the ring finger is longer, and they're saying to see whether someone's ring finger is longer than their index finger. So as it turns out, if you look at your hand, the ring finger would be like the 4th one from the thumb, and that's but the index finger is the 2nd one, right next to the thumb. So mine, if I hold mine up, it looks like it's about a tie. I see very little difference depending on which angle I'm looking at. The 2nd digit is shorter. Yeah, so mine looks like it's like typical, but there are a lot of exceptions. A lot of exceptions, because basically there's not too much difference there. So using this R code, what kind of value is in the variable ring longer? Either it's true or it's not, because we're comparing the ring part to the index part. If the ring is larger than the index, then it is longer, and that would be a true statement. So it's Boolean. There's no computations right now. It's just true or false. So now looking at how many people have longer ring fingers relative to their own index finger, what we could do on this one is we could take a look at the string that they've given us back here. So I'm going to go ahead and borrow that as I get that typed in and copied. Command C, go down here and get on the next line, I'll get Command V. So I've got that in there first. But now we have to get a tally. What are we going to tally? We'll have to tally the fingers $ ring longer. So this will tell us how many had longer ring fingers. So I'm just going to go ahead and copy this one, Command C, slip it inside the tally. That's Command V. There it is. It seems to be tallied, and our hint should have told us something just like this. Ring longer is stored as a column in fingers, so I'll have to access it like fingers $ ring longer when using the tally. So yes, I basically followed the directions. It's a little bit tougher than we've seen, but when you do that, we do have 89 of the people that did have longer ring fingers, but 68 did not. So as you see, it's more than 50-50, roughly 60% true, and that's the results they got. Okay, what does true mean? It means that the ring finger is longer. Yes, and almost everybody saw that, so that would be not a problem. And then, of course, true 89, we just said it, 89 people have longer ring fingers, but 68 had longer index fingers, because it was false the way it was originally written. So they usually try to write it in favor of the majority, I suppose, but maybe not always. Okay, so then we could take a look at a ratio. We could use arithmetic operators such as division. The ratio of index to ring, that is, the number for index divided by the number for ring, is often used as health research as a crude measure of prenatal testosterone exposure use the division operator, which is just the backslash, to create this summary variable. Okay, so in this particular case, what we want to do, and we already have the name of the variable, but how we're going to do this, we have to make sure we got that in there. So it's going to be fingers, that's the data set, and we put the $sign to make sure we get the correct variable. You did want the index over the ring, so let's make sure we got the index going there, and then I'll put a space in just to make it look a little bit more pleasant. And then I'll go for the data set again, fingers, remember the $sign, but now we're looking for ring. And let's see what happens when I go ahead and run it. Well, we need, of course, have it printed too, so I'm going to have to go down here, and instead of typing it, I'm just going to copy it down. So merely putting this on the next line will make sure it gets printed. You do not have to say print this, it's just that. So now we'll go ahead and run it, and that will also print it as well. And so, as you see, going way in the beginning, all these numbers are pretty close to 1. That ratio of index to ring here is about 1.067. This one's 0.97. Just about all the numbers were quite close to 1, either a little on the high side of 1 or on the low side of 1, or maybe exactly 1. There was one in here I found, it was like a 0.3. I'm not sure what happened there. That sounds like perhaps a mistake, or maybe somebody lost part of their finger or something, I don't know. But let's not worry about that right now. And be sure to submit it when you're done. How would this variable be represented in a tidy data frame? Well, index ring ratio, apparently, and this does look correct, would be represented as a new column in the same data frame. So with all the other columns we have for the variables, index ring ratio would have to be somewhere put in there. And that, where you want to put it, I don't know. You could slip it in where it's closer to the other ones, or maybe at the very end, or something like that. Okay, as we get closer to the finish here, whenever we make new variables or even do anything else in R, it's a good idea to make sure R did what you intended it to do. Yeah, I suppose so. You can use the head function for this, the top 6. Go ahead and print out the first 6 rows of fingers. Use select to look at ring, index, and ring longer. By looking at the fingers of the few students, you can see whether it wound up working out or not. So in this particular case, let's take a look at the hint. There's a lot happening here. We used head and select, so I guess that's going to be a thought. We can get head to make sure we get the top 6, and then we can use select inside that to make sure we're selecting the correct items. And that's going to be the variables that they're looking for. So first of all, we have fingers, because that's where the data set is residing, and then it looks like we have to hit comma, ring, and then I'm just getting the ones they have here, so ring index and ring longer. Here comes index for the second variable, and then ring longer, capitalize the longer, and that should do it. So in other words, we've got that going on, and let's just see what happens. Head doesn't need to be printed, it just automatically gives you the top 6. So let's go ahead and run. And unexpected end of input. So I've done something incorrect here. I'm not quite sure what it is. Head, select, fingers, ring, index, ring, longer. And not sure what I've done wrong. So if I submit this and take a look at the solution over here, okay, head, select, ring, fingers, ring, index, ring, longer. Isn't that what I typed? Head, select, fingers, ring. Oh, I don't have the extra parentheses. Silly me. Yes, type those parentheses in. Now we'll run it. And suddenly it works. Yeah, so here I am, guilty of my own poison, I suppose you could say. So here they've got them. The ring for this is 74. Here the index is 79. The ring is not longer here. In fact, that's not a close call. Here it's a tie to the nearest tenth, so that's also a false situation. But of course, when the ring is longer, it's true. In the second instance, 75 is larger than 73, a true statement. And for the last of the little R windows, we could take a look at the average finger length by adding up all the values of all 5 of these particular ones and dividing by 5. So this one is going to be put into average finger, into the fingers deal. So as you see in line number 2, fingers data set, $, average finger, abbreviated, of course. So now it's just a matter of creating the summary variable. Let's take a look at the hint. Add up all of these terms, all 5 of them, and I'll have to say fingers. That doesn't sound like it's the most efficient way to go, but that's just the way R works sometimes. So we'd have to make sure we put all that stuff in there. And fact, since it's already itemized here, what I did before, I'm going to do it again, is I'm going to copy all this stuff, and from the hint, and Command C, go back here to Command, and paste it over there, Command V. Trouble is, that's got commas, and I need plus signs. So let's make sure we replace all the commas by plus signs. That way we make sure it's added. Or you could just type it in by hand. That certainly would be one way to go. So now I've got all 5 of the fingers, and so we'll have to take all of this and divide by 5. So all of this, if I put parentheses around the thumb and put parentheses around the pinky, there's only one level of parentheses. But I will have to say over 5, and then of course I'd have to get that to work. And let's see, write code to look at this. So let's just run it. I haven't asked it to do anything, so I'm going to have to now go ahead and type in fingers $ average finder, AVG, and then capital F for finder, and a finger not finder, sorry, so I'll change that, and let's go ahead and run that, and here we have the average. So yeah, so here first average is 72, the second average is 70.9, 70.8. They've given us 3 decimals, which is more than we need, really. 1 would have been fine for this, but this time we've got the average finger length for each of the 150 or so people in the survey. And that's how we could do it. Just be sure you add up all the relevant information. It's just a straight old average. Step 1 in a statistics class is to find the mean. So we're doing it. And then we make sure to print it by typing the name of this. And of course, fingers data set, which we're saying over and over, along with average finger. And that would be certainly something that would be printed at this point. Okay, that should be plenty for today. We're getting pretty far into chapter 2, and so we still have, get to 2 and 3 and all, but we want to do some of those notebooks. I need to find out more about how that's done. We'll be back live on Thursday after Labor Day, and I believe that's, I'm not sure what day that is. Today's the 5th, so it'll be 5 days from now. That'd be the 10th. So September 10, we're back live. This is the lecture for the 8th, or maybe even the 7th, depending on if you're Monday, Wednesday. For Monday, Wednesday people, we'll be back live on the Wednesday, the 9th. So that's different for you guys. Got 2 sections Tuesday, Thursday, but I still have 1 big section of Monday, Wednesday, so I have to keep you guys in mind. And that's to be the last time you have to do a kind of a makeup lesson. Everybody's going to be in sync from here on in, barring any kind of other Zoom crashing or whatever. So that seems to do it, and I'll be back live again Wednesday and Thursday, and have a nice weekend, and be sure to email me if you have any concerns or questions. I'll see you later. Bye-bye.